Hey there, gang. In this video, we're going to look at how you can graph linear functions using tables. You'll remember in the last video, we saw functions can be represented by lists of ordered pairs, tables, and graphs. Well, they can also be represented by an equation. An equation is just a rule that tells you how to get an output value given a particular input value. The equation will generate ordered pairs by taking that input value, which is our x value, and results in a certain output value, and that output is the y value. The x value is what we call the independent variable, and the y value is what we call the dependent variable. So when we're talking about functions, y always depends on x. The graph of an equation is the set of all of its ordered pairs, and oftentimes you'll get either a line or a curve when you're graphing equations. So we're going to try a few problems here. On the first few examples, we're just going to complete the tables given the equation. So for number 1, I have the equation y equals x minus 13. And I've given you 4 x values, and remember these are the input values, and those values are 3, 6, 9, and 12. So I'm going to take each of these input values and substitute them in for x in my equation to get the y value. Okay, so I know y is equal to x minus 13. So if I substitute in 3 for x, that's going to be 3 minus 13. If I substitute in 6, that will be 6 minus 13. If I substitute 9, that's 9 minus 13. And if I substitute 12, that's 12 minus 13. So all I'm doing is I'm plugging each of those numbers in where I saw x in my original equation. When I take 3 minus 13, I get negative 10. So that's my y value when my x value is 3. When I do 6 minus 13, I get negative 7. 9 minus 13, I get negative 4. And 12 minus 13, I get negative 1. So my ordered pairs, my x, y values, for this particular function are as follows. I get 3, negative 10. I get 6, negative 7. I get 9, negative 4. And then I get 12, negative 1. Okay, so we're going to do this a few more times now for the rest of these tables in 2, 3, and 4. So number 2, I have a different equation this time. I have y equals 1 minus x. The ordered pairs they've given me are the x values they've given me are negative 5, negative 4, negative 3, and negative 2. So I'm going to take my equation and substitute each of those in for x. Now notice this time the right side of the equation starts with 1 minus, and then we see the variable. So I need to start each time with 1 subtract my x value. So 1 subtract, 1 subtract, 1 subtract each time. Since I'm subtracting a negative here, 1 minus negative 5, I'm going to put that negative in parentheses. So when I'm substituting in x, this becomes 1 minus negative 5. And the same thing is going to be true here, here, and here. I have 1 minus negative 4, 1 minus negative 3, and 1 minus negative 2. You'll remember from working with integers in years past that a minus minus really means plus. So this is really 1 plus 5, which gives us 6. 1 plus 4, which gives us 5. 1 plus 3, which gives us 4. And 1 plus 2, which gives us 3. So my 4 ordered pairs for this table are -5, 6, -4, 5, -3, 4, and -2, 3. All right, let's try number 3. This time the equation is y equals 1/2 x minus 9, and you're given values of -6, -2, 0, and 14 to plug in for x. So again, you're going to substitute those numbers in where you saw x. Everything else will stay the same. So I'm going to set up my column like this. And now I'm going to substitute in, first of all, -6. Well, we're going to have to do a little bit of order of operations here. Half of -6 is -3, so this is -3 minus 9. Here, when I substitute -2, 1/2 times -2 is -1, so this is -1 minus 9. Here, 1/2 times 0 is 0, so this is 0 minus 9. And then here, 1/2 times 14 is 7, so that's 7 minus 9. So I multiply my x value by a half first, and then I subtract 9. So my first y value, -3 minus 9, is -12. And then I get -10, -9, and -2. So my ordered pairs are going to be -6, -12, -2, -10, 0, -9, and 14, -2. Alright, I'm going to pause the video now, and I want you to try Table 4 all on your own. Once you get it completely finished, click play to check to see if you got it right. Okay, so if you did your table correctly, you should have the ordered pairs -9, 23, -3, 15, 3, 7, and 6, 3. So if you did not get those, please go back and check your multiplication and your addition over here in this column, especially that multiplication. You're multiplying -4/3 times the input value each time. Once you have that table looking good, go ahead and move along with me to the next set of examples. So in examples 5 and 6, you're given domain values and you're asked to find the range values for each function. And so even though there's not a table drawn, I am going to draw a table for each of these because I think that will just make your life easier if you are already doing tables to organize everything here in a table. So that's what I'm going to do. Just like you saw up above, I'm going to draw a table for number 5. So I'm going to put x values on the left side. We'll show some work here in the middle. And then on the right side, I'll have my y values. Okay, I don't really need to list ordered pairs for this one, so I'll leave that last column off. So my domain values, which again are your x values, domain's always x, are -2, 2, and 4. The equation, or the rule, is we take y equals -2x plus 5, so I'm taking -2x plus 5 to get the y value each time. So that means it's going to look like this each time. -2 times our input plus 5. So here I have -2. -2 times 2 is 4, so this is 4 plus 5. Here I have +2. -2 times +2 is -4, so that's -4 plus 5. And here I have 4. -2 times 4 is 8, so that's 8 plus 5. So I get 4 plus 5, which is 9 for this y value, -4 plus 5, which is 1, and then down here, oh, this should be -8, so that's -8 plus 5, which is -3. So I have 3 y values, which are my range values. So the range here is -3, 1, and 9. Remember to list those in braces from least to greatest. All right, let's do the same thing for number 6. So I'll set up my table. So this time my domain values, my inputs are -6, 2, and 7. My rule is I'm taking -4 and subtracting x, so I need some parentheses here where x was. And so I'm substituting in -6 here, 2 here, and 7 here. So at the top, -4 minus -6, there's that minus negative again. Remember, that means -4 plus 6. -4 minus 2 is just -4 minus 2, and then -4 minus 7 is just -4 minus 7. So -4 plus 6 gives us +2. -4 minus 2 is -6, and -4 minus 7 is -11. So our range, start with -11, that's the smallest, then -6, and then +2. Alright, going to the back side, this time we're going to put the tables together with some graphs. So we're going to do the same thing we've been doing. We're going to complete each table given the equation, and then once we have our ordered pairs, we're actually going to graph each equation. So this first equation here, y equals x plus 3. So I'm taking my input value, and I'm adding 3 each time. So this will be -7 plus 3, -3 plus 3, 0 plus 3, 2 plus 3, and 5 plus 3. -7 plus 3 is -4. -3 plus 3 is 0. 0 plus 3 is 3. 2 plus 3, 5. And 5 plus 3, 8. So my ordered pairs here are going to be -7, -4, -3, 0, 0, 3, 2, 5, and 5, 8. So now that I have those ordered pairs listed, I'm going to plot those ordered pairs on my coordinate plane. So -7, -4 will be here. -3, 0 here. 0, 3 here. 2, 5 here, and then 5, 8 right there. Whenever you're graphing an equation, you always are going to connect your points. Okay, so equations give you continuous graphs, so make sure you connect your points whenever graphing an equation. So if your equation is a line, you want to get a ruler and connect those points. So make the line as straight as possible. So that's going to look like this for our graph. Alright, so that's what your graph looks like. Let's look at the second equation. This time it's y equals x squared. Remember, when you square something, you take it times itself. So here, this is going to be -3 squared. Here, this is -2 squared. Then we'll have 0 squared, +2 squared, and +3 squared. -3 squared is +9, -2 squared is +4, 0 squared is 0, and then 2 squared is also 4, 3 squared is also 9. So my ordered pairs are -3, 9, -2, 4, 0, 0, 2, 4, and 3, 9. So I'm going to plot each of those ordered pairs. -3, 9, -2, 4, 0, 0, 2, 4, and +3, 9. You'll notice that this graph does not form a line. It in fact forms a curve. It's sort of a U shape. So I'm going to connect those points as a smooth curve, just like this. And so now let's talk about those two graphs that you got here. So the first equation, the one on the left, produced a line. And anytime you have an equation that produces a line, it is called a linear equation, or a linear function is what we'll sometimes call that. The second equation produced a curve, and this particular equation is known as a quadratic equation. So you'll find in Algebra 1 that there are two big types of equations that we study over the course of the year. In the first semester, we're really focused on linear equations, and in the second semester, we're really focused on quadratic equations. So we will focus on graphing linear equations in this unit, so equations like the one on the left, but just know that by the end of the year, we'll also be graphing quadratics, so those that look like the graph on the right. Alright, that's all I have for this video. If you have any questions, make sure those are written down. And until I see you again, have a nice day. You're all wonderful people.